All right, number 10 here. So for this one, we're going to start off with the parent function, the absolute value of x, and we're going to reflect it across the x-axis. So an x-axis reflection is a negative outside. And so I know when I have my absolute value here, I'm going to have a negative on the outside. We have a shift 2 units to the right, so that's going to be x minus 2. Remember, the left and right is always kind of counterintuitive. And then the up 9 is intuitive on the outside there, so that would be my function right there. All right, next up here, we're going to go through this graph right here and kind of analyze it. So we start off, it asks for the domain. And so if I'm kind of tracking my x values here, I see we start at -4 with a closed dot, but then we actually stop for a little bit at 3 with an open dot. And then I pick it back up again at 2 and then go to 1. And then it stops again. And then it picks up again at 0 and then goes to 2. And then it stops again. And then it goes all the way from 3 to 5 uninterrupted. So I would say that's the domain. The range here, let's see. It looks like if I'm looking at y values that this piece right here takes up a big chunk of it from -5 to 3. And I would stop it at a bracket there, but since this 3 value, y value over there is a closed circle, I can actually do a bracket. Otherwise, I would use a parentheses. And then I would take a break, and then we have one isolated y value of 4 there. So then it looks like that one right there. All right, so then increasing versus decreasing. So I see that it will be increasing here, I would say, on this once again, this first piece. I'll color code this. I'll do this one in pink. So this will be increasing here and then also increasing right there. So I would say bracket -4 and then to -3. And I'm going to use a parentheses there. I think it doesn't really matter, but since that one's a closed dot versus an open dot, if you're having issues with this, go ahead and try it using the bracket and parentheses that I used here. And then also, I'll make this a parentheses here from 3 to 4. So I'm describing that with the x values there. I'll close that with a bracket since it's a closed dot. All right, so then decreasing, it looks like it would be just this piece in the middle here. And so that would be from bracket 0 to 2 parentheses. And then constant, I think I actually have 2 constant spots. So I'm going to say that that is right here and right here. So I'm going to say from -2 to -1. And then from 4 to 5. All right, next up here we have a word problem, and it looks like the information given is in 2 points here. And so it says $380 to drive 480 miles, but I see here that x is the miles, and so I'm going to write that as 480, 380. And then my other point for me will be a 760, 450. So I would go ahead and find the slope here. And so we do y2 minus y1 over x2 minus x1. And so this will come out to 70 over, let's see, that's almost right. That'll be 280. So that'll be 1/4. And so that's my slope. And so now I would do a point slope form. So I'd say y minus 380 equals 1/4 times x minus 480. I would probably recommend putting this into slope intercept form. So I'll go ahead and distribute that 1/4 in there. So y minus 380 equals 1/4 x minus 120. I'll add the 380 over. And that'll give us, I'll put this up here, y equals 1/4 x plus 260. And so that'll be my answer right here. It did say to use x for miles, so obviously this is not y equals, it's c of x equals, but that's the right expression on the right side. All right, and so I'm going to be looking here for, and I see really quick, it's right here. We're looking for a positive slope with a y-intercept of 260. So we know that the slope of this line is obviously 1/4. And then at what rate is the cost increasing for every additional miles? And I would say that that is, since it's dollars here, it's going to be $0.25. I think we know that's 25 cents, but since that kind of dollars is right there, I have to put it as $0.25 dollars. All right, on this one, they're asking me for the net change. So the net change is really just like y2 minus y1. It's just the top of the slope formula. And so I need to find these y values. So I'm going to find g of 5, which is going to be 5 to the 4th, minus 5 to the 3rd, plus 5 squared. So it's going to be 625 minus 125 plus 25. And you can really add these in whatever order you want. So that would be 500 plus 25, so that'd be 525. All right, and then g of negative 5 is going to be negative 5 to the 4th minus negative 5 to the 3rd plus negative 5 squared. Now on this one, the negative 5 to the 4th is going to stay positive. However, this middle term is going to switch to plus 125, and then this last one is going to stay at plus 25. So we see that for negative numbers inside of exponents, whenever it's even, it's going to kind of stay the same. The odds, or the evens are all going to turn positive, so it's going to be the same as last time. The odds are going to kind of stay negative, but since there's a negative in front of the negative, that's what switched that to a positive. So we do get different answers for these. So this one is going to come out to, let's see, 750, 775, okay? So we're going to subtract these two y values, but we do have to go in order here. So I have to do the 5 first. That's the 525 for me, the answer when I plugged in the positive 5. And now I'm going to subtract that from the number when I plugged in the negative 5. So that's actually going to come out to a negative 250 here. So if you're getting a wrong answer and you're pretty sure you did it right, a lot of people will do this backwards, and that'll give you a positive 250 for this one. You might still get the answer for part B right, but this one has to be y2 minus y1. All right, so now part B, average rate of change. I take that that net change and divide it by x2 minus x1. Now in this case they are t values, but same idea. So negative 250 over 10 is just going to be a negative 25.